So now we're going to go over some examples for the product rule for exponents. I'll remind you that it reads this way. If x, p, and q are all real numbers, I know the book says positive integers and then later it says negative integers. They can be real numbers actually, p and q. Then x to the p power times x to the q power is x to the p plus q power. We add those exponents in order to multiply these powers. Okay? Let me give you an example of why that is real quick first. So, how do we interpret x cubed? X cubed is expanded as x times x times x, right? And then that multiplication symbol here is in between. And how do we write x squared? It's x times x. That means that this 3 and this 2 count how many factors there are for x. So it makes sense to add 3 of them to 2 more to get x to the 5th. 3 plus 2. Let me put it in the order it originated in. X to the 3 plus 2 is x to the 5th. And yes, there are 5 x's there. So that's why we add them, because these are not real numbers in this situation. They're counting how many factors we have. To count them all up, we add those counters. Okay, so that's the explanation of why that works. Now let's apply it to a more complicated problem. Here's a problem here. I want to remind you that in this product rule, the x's have to be the same base. If that was an x and this was a y, we couldn't combine those two powers into a single power like this, or like that. If that was x cubed y squared, it'd have to stay that way. So here we have several powers of variables that are different bases. We can only combine the ones that have the same base. Now remember, we're multiplying here. So whenever we have numbers, we're going to multiply those numbers. Not going to add any exponents. They're not the same base anyway. We wouldn't be able to add their exponents. So, to simplify that, what is negative 2 times 3? Well, that's negative 6, right? And now, let's find the ones that have like bases. Here's an x squared. Here's an x cubed. That x squared and that x cubed, just like we did here, there's x squared and x cubed there, would combine to get x to the 5th. Okay? And here's another base that's the same in both sets of parentheses. There's a y cubed here and a y cubed here. Y cubed times y cubed is y to the 3 plus 3 power, or y to the 6th power. The other bases we have here are p and z. They are not alike. So we can't add their exponents or combine them in any way. So we're just going to write them again. P cubed, z. And z has a 1 exponent, but we don't have to worry about that. If we had another z here, we'd add that to some other exponent. So here's our final answer. Those x, y, p, and q, p and z, rather, bases can be in any order. Usually put the number in front, but that's your final answer for this one.